Okay, part 2 of this circuit. Previous video explained everything I did across here. I'm going to go back to the small scope. It is my firm belief on the Stephen Mark TPU that the thumping is these pulses lined up harmonically around the ring. You can capture all day long with a capture circuit and it's not going to thump unless you have it resonating at a certain frequency that matches the geometry and the harmonics. In a ring, since it goes around, you got boom, 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 we can pick a spot to make this vibrate at. The matching spots where they end up on the ring are based upon, one, the frequency, which matches up with the inductance of the windings and the circumference of the ring itself. So those are 3 parameters going into this. All of Stephen Mark's TPUs thump. And when this circuit is set up correctly and you get the resonance just right, and these guys hit bang on, but kind of off in his description, you'll get the thumping. There. It's more of a chirping configuration. And as you can see, they go from left to right. It's another scenario I have to look into, is the left and right. How is that hookup to make the scope show this on this ring? How is that hooked up? These are firing counterclockwise from this view. All frequencies go the same direction. So that's my next test. And now that I have this platform that runs, and I can play with it, now I can sit there and screw around and control things a lot better than what I had before. Previous circuits before would just thump and then take off, and there'd be a solid megahertz run across this. This says 1 megahertz, but I've only got 1K, 3K, and 4K running into these rings. The slower frequencies are in the center. The faster and frequencies go into the outside. One of the feedback mechanisms I have is I have A, which is the slow one, gating a FET, which allows the B channel to parallel with the C channel. So you get a very high reactive circuit here. So as I'm driving A, B, and C, A gates B through parallel to C. So B and C are sitting there banging on the C outer layer via the on time and off time of A. It's a very interesting process. The coil sits with these FETs, but the situation, the driving situation, actually sits between 4010s, a set of 4010s, and so I can show you the output. The 4010 outputs are facing. The outputs are facing towards each other. So you have 4010 facing this way, the coil, and then a 4010 facing this way. Oops. I should draw that on a piece of paper. Here. Here's a schematic. As you can see, this 4010 going out, there's your coil, there's your coil drivers, and this 4010 is facing out also. Very low current, only 75 milliamps at 9 volts across these tank circuits. So this is what it looks like. It's a very odd circuit. Let me, so you can see that. I'll zoom in to this is the main frequency driving in to this gate, got this buffer through. I'm sorry, this is feedback frequency. Nope, I got this wrong. These two things here need to be switched. You can see A goes to the gate, lets B come through, B comes in parallel with the C driving line. So that's it in a nutshell. That's all. And I should stipulate also that the other two coils, A and B, are also sitting in parallel with C.